We are reviewing for the finals today for my Math 3 class. It's a trigonometry review, and the first question is evaluating trig functions without a calculator. So in order to do that, I like to use a unit circle in which we can clearly see what goes where. So I'm going to put it right here on the coordinate axis so that we can refer to it. So sine 60 degrees is going to be about here, and then you can see that sine is going to be equal square root of 3 over 2. Those are our values that we have to have memorized. Cosine of pi over 4 is going to be right here. Cosine is going to be equal square root of 2 over 2. I'm going to put an equal sign here. Tangent of 135. So 135 is going to be over here. We know that the tangent is going to be negative, and we see because it's half of your quadrant, it's going to be -1. Secant of 60 degrees. Secant, we're back to 60 degrees. Secant is 1 over cosine in this case. Cosine is going to be equal 1/2, so secant has to be equal to 1 over 1/2. And then cosecant pi, that is the point over here on the unit circle. Cosecant is 1 over sine pi, but sine is going to be 0, so cosecant pi is going to be undefined. Undefined. All right, moving on. Cotangent 5 pi over 4. If you don't remember this trick, I'm going to teach you how to very quickly figure out where 5 pi over 4 is if you didn't memorize it. So this is pi over 4, pi over 4. This is going to be 2 pi over 4. Then half of this quadrant is 3 pi over 4. Then we have 4 pi over 4, and then 5 pi over 4 is going to be in the third quadrant over here. Cotangent, we're looking for cotangent. It is going to be cosine over sine, but both sine and cosine are -1 here. So -1 divided by -1, that's a +1. Cosecant of 330, that is our angle somewhere here. Cosecant is 1 over sine. Sine is 1/2, so cosecant is going to be 2, but it is below the x-axis, so it's -2. Sine of -45. -45, we have to go in the clockwise direction. -45 is going to be here, and we're looking for the sine, so sine has to be negative again, and it's square root of 2 over 2. Cosine of -2 pi over 3, so we're going pi over 3, 2 pi over 3. So cosine of -2 pi over 3 is going to be over here, it's going to be -1/2, -1/2. So that's the distance. And then cotangent of 3 pi over 2, pi over 2, 2 pi over 2, 3 pi over 2. Cotangent is cosine over sine, right? Cosine is 0 of this value, so it has to be equal 0. Find two solutions of the equation. Now, our second problem is about equations. Find two solutions of the equation, give you answers in degrees and radians, and within one rotation. So between 0 and 360 or 0 and 2 pi. Cosecant equals -2. We know that cosecant is 1 over sine theta, which is equal -√2, which tells us that sine theta has to be equal 1 over square root of 2 or square root of 2 over 2. I'm going to put it over here. So sine theta has to be equal negative square root of 2 over 2. So it's going to be a value either over here or over here. So that means that our angles are going to be, this is 5 pi over 4. This would be 7 pi over 4. So theta is 5 pi over 4 or 7 pi over 4 if we give the answers in radians, but we also need to give the answers in degrees. In degrees, our answers are going to be, remember, 45, 90, 135, 180, 225 degrees. And this one is going to be 315 degrees. 315 degrees. All right, secant theta is -2 root 3 over 3. So secant is 1 over cosine. So cosine theta is going to be equal negative. And then if you flip this, you're going to get 3 over 2 root 3, which you can simplify to get square root of 3 over 2. negative square root of 3 over 2. Cosine, negative square root of 3 over 2, it's going to be the value over here and over here. Okay, so that's going to be our pi over 4, 2, 3, 4, 5 pi over 4, over 6, 5 pi over 6. And then this one is now 7 pi over 6. So theta equals 5 pi over 6. 7 pi over 6. In degrees, it's going to be 180 minus 30 degrees, which is 150, and then plus 30 degrees, which is 210. So theta equals 150 degrees and 210 degrees. And then finally, cosine theta equals 1/2. So cosine is the x value. 1/2 means that you have this value, which is 60 degrees, and then another one, which is 300 degrees. 300 degrees. Shouldn't have done it over here. Should have done this one over here. 300 degrees. In radians, so 60 degrees and 300 degrees. In radians, it's going to be, what is it, pi over 3, pi over 3, 2, 3, 4, 5 pi over 3. 5 pi over 3. That is our question 2. In question 3, we're finding the angle in quadrant 2 if the sine is given to us, and we need to figure out the other 5 trig functions. So in quadrant 2, our angle is going to have, the sine is going to be 1/3. So we can say that if this is our angle theta in quadrant 2, sine opposite is going to be 1, hypotenuse is going to be 3. We need to figure out the adjacent side. To do that, we're doing 3 squared minus 1 squared, which is going to be 8. And then we have to take the square root of that to figure out our adjacent. And we have to make it a negative, because it's in the third quadrant, in the second quadrant, sorry, it's negative. Negative square root of 8 is negative 2 root 2 after we simplify this. All right, find the other 5 trig functions. So we just found that cosine theta is going to be equal negative 2 root 2 over 3. Then we can find tangent theta, that is going to be, I'm going to label this one here. So tangent is opposite over adjacent, so that's going to be negative 1 over 2 root 2. Once we rationalize the denominator, it's going to be negative root 2 over 4. You're multiplying both numerator and denominator by square root of 2. And then we find the reciprocal function. So cosecant theta is 1 over sine, that's going to be 3. Secant theta, that is 1 over cosine, that's going to be negative 3 over 2 root 2. Again, we're rationalizing denominator, and then we're going to get negative 3 root 2 over 4. And then for the tangent, I'm not going to find the reciprocal of this. I'm going to find the reciprocal of this one. So for cotangent theta, I'm going to get negative 2 root 2. Or you can just do adjacent over opposite, negative 2 root 2 over 1. Okay, so that's our problem number 3. Moving on to problem number 4, tangent plus cotangent over secant times cosecant. I would probably convert everything into sines and cosines, and then bring them all to the common denominator. So that might be a little bit ugly. I'm going to pause it for a moment and then unpause it once I write down a bunch of stuff. Once I change tangent, cotangent, secant, cosecant into sines and cosines, you can see that the denominators are going to be sine, cosine. So I'm adding those two fractions. So look at this. You have the same exact denominators, which means that they can cancel. Sine squared plus cosine squared, we know that is 1. This numerator is 1, so 1 over 1 is going to be 1. Number 4, the answer is 1. Number 5, it's kind of like what we had over here. So the common denominator is going to be cosine times sine theta. I'm going to write down sine theta first times cosine theta. Okay, which means that the first fraction has to be multiplied by sine theta. That's how you get sine squared theta. Sine squared theta. And then the second fraction has to be multiplied by cosine theta, which gives us cosine squared theta. sine plus cosine, sine squared plus cosine squared, that gives you 1. And then you have sine theta, cosine theta. You can leave it like this, or you can convert it into what we had over here, which is cosecant times secant theta. Secant theta times cosecant theta. So that one is your choice. When it says simplify, you can leave it either like this or like this. Number 6. Tangent plus cotangent times sine plus cosine theta. So I would convert this into sines and cosines. We already know that we have sine theta over cosine theta plus cosine theta times sine theta, keeping sine theta plus cosine theta over here. So for the first parenthesis, we already know that we are going to get 1 over sine theta cosine theta. And then this one, I'm just going to write it down on the top in the numerator. So I have sine theta plus cosine theta. And then I'm going to divide, to split this fraction into 2. So sine over sine cosine, which is going to give me 1 over cosine theta. And then plus cosine over sine cosine. That way cosines cancel out. So I have 1 over sine theta. And then we can convert those into secant theta plus cosecant theta. And that's our answer for number 6. We have total of 51, so brace yourselves. Sketch the graph of the function, include 2 full periods, state the start and end of the period, amplitude, and phase shift. All right, so I'm going to bring this one down a little bit and make it a little bit smaller so that I have a little more space. Mm. For the first function, we can see that the midline is going to be at 2. So I'm going to say this is x, this is y. The midline, let's say this is the midline, this is 2. And then the amplitude is going to be also 2. So it's going to go up to 4 and down to 0. So our graph is going to alternate between 0 and 4. The 2 full periods. So the sine graph is going to start at the midline, and then it's going to go up, down, and then up, down. Since I need to graph 2 periods, I'm going to kind of like sketch for myself the points. That would be 1 period, right? And then I will have another period going like this. Beware of just connecting those. That way you will not get a sine graph. You need to make your graph very smooth, and it should look like a curve. It's a little hard to graph on the trackpad that I have on the pad. So it should be, oops, a little smoother than what I got here. Especially over here, right? Should look somewhat like that. Okay, that's a little bit better. Okay, so that's our graph. And then now we need to label the period. So we have 2x over 3. So normally we know that the period equals 2 pi. So to figure out the new period, we're going to take 2 pi, and then we're going to take 2 over 3, because 2x over 3 means the coefficient in front of x is 2 over 3. And then we're dividing 2 pi by 2/3. So it's the same thing as saying 3 pi. Okay, because this 3 goes to the top. So imagine you're multiplying this times 3 and this times 3. The 2's cancel out, and then you have 3 pi. So from here to here, this is 3 pi. So if this is 3 pi, then this one is going to be 3 pi over 2. And then half of that part over here, it's going to be 3 pi over 4, right? And then half of this part over here is going to be 9 pi over 4. So that is our graph. And I just realized that I labeled 1 period instead of 2 periods, so I'm going to erase what I just wrote down, and we are going to go ahead and fix it. This happens with anybody. So 3 pi is actually over here, it's 1 period, right? 1 period. 2 periods would have been 6 pi, which means that 3 pi over 2 is this one, 3 pi over 2, and this point is going to be 3 pi over 4. I don't have space, so I'm not going to label it. And then at this point, we are going, at this point, we are going to have our 3 pi over 9 pi over 2. 9 pi over 2. So we're multiplying this guy by 3. So because we have 3 pi over 2, another 3 pi over 2, and another 3 pi over 2. So 9 pi over 2. So that's our graph now. All right, moving on to the next one, -1 minus cosine pi x. So we know that the midline is going to be at -1. The period is going to go from, the amplitude is going to go from 0 to -2. And we have negative cosine. So cosine would have started on top and would go down and up. Since it's negative cosine, it's going to actually start over here, and then it's going to go, oh, maybe like down like this. Okay, let me try to redo this. So it's going to cross the midline, go here, cross the midline, go here, cross the midline, go here, and then cross the midline, go here, since we're doing 2 periods. And then this line should have went a little bit further to the right, so I'm going to just continue it here. Okay, this is x, this is y. And now for the period. So again, to figure out the period, we're going to divide 2 pi over the number in front of x. So that's going to be 2. So now 1 period over here from down, up, down, that's going to be 2, which means that this one is 1, and this guy is 3, and there is a 4 over here. I have x, so I'm not going to write down 4. So that is that. For the phase shift, there is no phase shift in either one of those, right? There are no parentheses. However, there will be a phase shift in this last graph where we're getting there. Okay, we have 2 cotangent of x over 2. I'm going to actually start with the period. The period here is going to be pi over the number that we have in front of x, which is 1/2. So that's going to give us 2 pi for 1 period. The amplitude 2 is just going to stretch our cotangent. We are not even going to see it, because if you would have just regular cotangent, it would go more like this, right? And then if you have 2 times cotangent, well, it's going to go a little bit less prominent over here. Okay, now we need to figure out where the asymptotes are. The asymptotes are where sine of x over 2 is going to be equal to 0. So sine of x over 2, because cotangent is cosine over sine, sine of x over 2 equals 0. That means that x over 2 would have to be equal pi, 2 pi, and so on, right? Pi n, which means that x is going to be multiplied pi n times 2. So x is going to be 2 pi n. That's where the asymptotes are going to be. And why we started from the period here. Here we did it in sines, cosines, we did it at the very last moment. Here we started with it because we need to start with drawing the asymptotes. Now let me erase my calculations here so that I have space. So now I know that the asymptotes are going to go at every 2 pi n, so every period. And I am going to sketch them. So let's say this is going to be 2 pi, and this is going to be 4 pi. So I am just sketching asymptotes at this point. And then, so this is 2 pi, this is 4 pi, right? Another asymptote goes through 0. This one is going to be 6 pi, x, 0. And I know the cotangent has this shape that goes from the top left to the bottom right, and it has to go through the middle here. And I'm trying to make it stretched out, right? So I'm not trying to graph it like this with a very prominent kind of like break here, but it's pretty stretched. All right, so that's our cosine, the 2 cotangent of x over 2. And then finally we needed to graph 2 periods. We actually included 3 periods here.